Okay, now it's recording. So with the line y is equal to mx plus c, there are two ways to sketch it. The first way is to find the x and the y intercept. So the first one, you make y equal to 0, solve for x, and then the next one, make x equal to 0, solve for y, and then you connect those 2 points with a line. So if I look at a line that I have over here, I have y over 3 plus 2x over 3. This is equal to 1. Now if I want to sketch it in that way, I can find the x and the y intercept. So my intercepts, when I make x is equal to 0. Now with the intercepts, I do not need to first write it in standard form and then substitute. I can substitute right there. So I'll have y over 3 is equal to 1. And this means that y is equal to 3. Okay, and then I make y equal to 0. Now if y is equal to 0, when I substitute that, I'll have 0 over 3. Then I have 2x over 3 is equal to 1. And this means that x is equal to 3 over 2. So now to sketch these points, and then I will connect them using a straight line. So I'll draw my x and y axis. That's the x axis. This is the y axis. Then the x intercept, we said x is equal to 3 over 2. So the point is 3 over 2 comma 0. So if I put this, let's say 1, 2. So 3 over 2 is 1.5. So I plot it over there. And then the other one, this is 1, 2, and 3. The y-intercept was 3, 0. So that's how I would plot it. And then I take my ruler and then I connect them like that with the ruler. So I don't have a ruler for this, but you get the point. Then I'll label the line y is equal to mx plus c. Just label it over there. Now the second way we could do this is in the same way. So I need to label my points. So here I'll put 3 over 2. Here I put 3. The equation of the line, my x and y axis are labeled. Then I get all the marks. So that's very simple. Then I say the other way to draw it is to use the gradient instead. So I have the equation. Yes.
So if I substitute like x0, then I have 3, then the y, it will be 0, comma 3. Does it give me a coordinate after I
Yes.
substitute 0?
Yes, 0,
Oh,
3, because the coordinate is an x coordinate and a y
oh,
coordinate. So if you
oh,
substitute
okay.
x is equal to 0, then it's 0, whatever you get out of that.
Okay, man. Thank you.
All right. Then the equation again, this is y over 3 plus 2x over 3 is equal to 1. Now the second way to do it, I need to find out what the gradient is, and to do that I write this in standard form. So I have y over 3, this is equal to negative 2x over 3 plus 1. And then I multiply by the denominator over there so that I have y alone. So I have y is equal to negative 2x plus 3. So here my gradient m is equal to negative 2. Now we know the formula for the gradient. This is just delta y over delta x. That's how we get the gradient. So we're going to use the intercept and the gradient. So this is how we do it. You draw your x and y axis. These must be labeled x and y. Then you plot your value of c, that is 0, 3, so that's somewhere there. Then what you do is this gradient that you got over there, you write it as a fraction there, delta y over delta x. And the easiest way to do it is to write it as minus 2 over 1. Okay, so delta y, that means from this point over here, the y should go 2 steps down. Okay, so I'm going to move 2 steps down, so that's minus 2 and minus 1. Yeah, so I'll end up there. And then the delta y is positive. That means at the x coordinate of C, I need to add 1 unit. So I combine those two. I go down 2 steps, 1, 2, and then I add 1 step in the x direction. So I end up over here. Okay, so this coordinate over here, this is 1. Then I will take my ruler and connect them, and you will actually notice that this point is 3 over 2 like we did above. So I label my graph y, or my line y is equal to minus 2x plus 3. Okay, so those are the two ways of drawing the graph. It doesn't actually matter which one you pick. So it's just, I think some of you may have done it already. So again, from this intercept that I have over there, what I do is I move 2 units down. So this is minus 2. And then there, that is 1 unit. Because when I pick this point over there, its coordinates are 1, 1. And then I use it with the y-intercept, you will see that the gradient is equal to minus 2, which is what we wanted. So you can make your gradient even minus 4 over 2. You will see that if I move 4 units down, this is 1, 2, 3, 4, and then I move 2 units to the right, I get a point that's over there, but it's still on the line. So it doesn't matter whether you use your gradient as just minus 2, or if you use it as minus 4 over what is it, minus 4 over minus 4 over 2. It doesn't matter, as long as when you simplify it, you get minus 2. Okay, so there are more examples of lines to draw. I don't want to spend too much time on that because lines, like I said, you've been doing it since primary school, so that one is not a problem. Then the parabola, again, which I'm sure should not be a problem. The parabola. Now a parabola looks something like that. Okay, so the ones we will do will open either upwards or it opens downwards. And the equation of a parabola in standard form is y is equal to ax squared plus bx plus c. This is it in standard form. Y is the subject of the formula. Now with this one as well, c is your intercept, because if you make x equal to 0, you will end up with just c. Okay, now the parabola, like I said, opens upwards or downwards. Now what determines whether it opens upwards or downwards is this value here, a. Now if a is positive, okay, you can imagine a positive person. This is a positive person. Here they are smiling. So a parabola with a value of a greater than 0 looks like a smiley face. So this parabola over here is when your a is greater than 0. Then when a is negative, a is less than 0, you can imagine a negative person, they have a frowny face. Okay, and a parabola where a is negative opens downwards. Now this graph, sorry, I think somebody's in the lobby trying to join the class. Let me just get them in. Okay. All right. So that is how you know whether your parabola opens upwards or downwards. If it opens upwards like this one, it has a minimum, because this point over there at the bottom, this is your minimum. And if it opens downwards, it has a highest point, and that point is your maximum. So when you sketch a parabola, this is basically what I want to see. I want to see the x and y axis labeled. I want to see, if it opens like that, I want to see this point over there labeled. So you need to tell me what is that point there and what is this point there, what is this intercept there as well as your minimum or your maximum. Okay, and then you need to label your graph. So all those things are what counts for marks. Your x and y axis should be labeled, your x intercepts should be labeled, your minimum or maximum turning point should be labeled, and label the graph itself. So let's look at one example where we have to sketch. So we have y is equal to x squared minus 3x. Okay, so we know what we need. We need the intercepts where x is equal to 0, then where y is equal to 0, and then the minimum. Now this minimum or maximum, we get it from completing the square. So that means we write our equation in this form: a x minus p squared plus q. Okay, then when it is in this form, the minimum or the maximum or your turning point is this point here, p comma q. So to get p, I just take this equation over there, equate it to 0, and then solve for x. I'll get x is equal to p, and then this q over there as it is. All right, so back to our question: y is equal to x squared minus 3x. So we can start by finding the intercepts. So we look at the intercepts. Okay, when y is equal to 0, this means x squared minus 3x. This is equal to 0. Okay, then we can factorize this. This is x minus 3. This is equal to 0. And this means x is equal to 0, or x minus 3 is equal to 0. And that means x is equal to 3. Okay, so that's the first one. And then the second one, when x is equal to 0, we have y is equal to 0 squared minus 3 times 0. This is just equal to 0. So those are my intercepts. So I have 3 out of the few things that I need to work out. I need to also determine, does my parabola open upwards or downwards? So I look at the equation: y is equal to x squared minus 3x. The coefficient over here is 1, and 1 is greater than 0. So this is a positive number, and positive people are smiling. So my parabola is going to open upwards. Okay, so I've already determined the intercepts, the shape, that means whether it opens upwards or downwards. I just need the minimum turning point. So this one has a minimum turning point. The turning point. And we say to get the turning point, you just complete the square. So we have y is equal to x squared minus 3x. You know how to complete the square. Y is equal to x minus 3 over 2 squared minus 9 over 4. I know we did this, we spent some time on it, so you should remember how to complete the square. If not, please go and revise your notes, and then you will see, oh, that's how we complete the square. Okay, so now that we've written it in that form, we can say that our minimum turning point is this. So I will equate this to 0 and then solve it. That means I get 3 over 2. And then I take this as it is. So this is minus 9 over 4. Okay, that is my turning point. So I've worked out the x and y intercepts. I have my turning point. I know that it opens upwards. Now the only thing left is for me to sketch. So your sketch doesn't have to be like a perfect scale, but it must make sense. So again, I label my X and my y-axis, very important. Then I'm going to label my x-intercepts. So the first one we said is x is equal to 0. And then the second one was x is equal to 3. So if this is 1, 2, 3, so 3 will be here. So I'm going to label it over there. Then the y-intercept we said was 0. And no, not 0, it was 3 over 2 comma negative 9 over 4. So 3 over 2 is 1.5, so it goes somewhere there. And 9 over 4 is 2.25, so this is 1, 2, so it'll go somewhere there, and that is where the minimum will be. So I label it, this is minus 9 over 4, and this point over here, this is 3 over 2. Okay, and I said it opens upwards, so I join all these points with a parabola that opens upwards. So it must be smooth. I know on paper it's much easier to draw than it is over here. Okay, so it should not be pointy like that. No, it must be smooth. And I know on paper it is easier to do than I'm doing here. Then you can draw a dotted line to the point like that, just to show me that the coordinates of that point, your minimum, is 3 over 2 comma 9 over 4. So you can draw either the dotted lines like I've done here, or write it like that. You don't have to do both of them. And then you label your graph, y is equal to x squared minus 3x, and then you are done. So I need to see all these things. I need to see the x and the y axis labeled, the x-intercepts clearly shown. So here I know it's at the origin, so that's obviously a 0. This 3 over here, it's clearly labeled. And then this 0 over here, the origin is both my x and the y-intercept, so maybe there's like 2 marks for that. And then your turning point, either label it with the dotted lines over here, or next to the point you tell me what the coordinates are, and then your graph must also be labeled. And then the graph must look like a parabola. It shouldn't look like 2 lines connected to make a V. That is not a parabola. Okay, then you get all the marks for that. Do we have questions on that one? Or is it fine? Okay, looks like it's fine. Then we have the hyperbola. Now with the hyperbola, there are 2 types that we have. We have the rectangular, which is the first one we'll look at. Rectangular parabola. Now the rectangular parabola in standard form, so let me write this. In standard form has this equation, xy is equal to k. So you're multiplying x and y to give you k, where k is some constant. Now k here is not equal to 0, because if k is equal to 0, it means either x is 0 or y is 0, or both of them are 0. Okay, and then that wouldn't give us a graph. Okay, now this relationship over here, xy is equal to k, that is what we call an inversely proportional relationship. Inversely proportional relationship. So that means when one of them increases, then the other one decreases. Now we can have 2 scenarios. The first one is when k is positive. Let's say I give you this hyperbola, to sketch. X times y is equal to 2. In this case, k is equal to 2, and k is positive. Now, if we look at what I'm doing here, I'm multiplying, and my answer is positive. It means x and y must both be positive, or x and y must both be negative. So both of them must be positive or both of them must be negative so that their product is positive. And if you look at your quadrant or your quadrants, the x and y axis, this is x and that is y. Now the quadrants where they are both positive is the first quadrant. So the hyperbola looks like that. And where they are both negative is this over there. So a parabola is like two pieces of the same parabola. So you have one in the first quadrant where they are both positive and another in the second quadrant where they are both negative. Now they form a rectangle here. That is why we call it a rectangular parabola. Now with this one that I've drawn here, let's say it's x times y is equal to 2. So here, this distance is square root of 2 in the y. This is square root of 2. Well, let me write it on the axis. So this point here will be square root of 2. And then this point over here is also square root of 2. Because this point here, which is square root of 2, comma square root of 2, when I multiply square root of 2 times square root of 2, I get 2. So when I multiply the x and the y, I get 2. And the same thing over here, because it's just a reflection, here I have negative square root of 2, and over here I have negative square root of 2. So this point here on the hyperbola has the coordinates negative square root of 2, comma, negative square root of 2. So that when I multiply the two of them, the answer is positive and it's equal to 2. Then the second scenario is when k is negative. So
Miss,
k, yes.
ma'am, can you please repeat the first scenario? Because my
Repeating you can do by watching the video again, unless you have a specific question.
okay, ma'am, I'll rewatch it.
Okay. All right. So here, when k is less than 0, it means either x is less than 0 and y is greater than 0, or x is greater than 0 and y is less than 0. So one must be positive and the other one negative. Otherwise, the product cannot be negative. So you look at which quadrant do we have where one is positive and the other is negative. So this is my x and that is my y. So in the second quadrant, we see that x is negative and y is positive. So a hyperbola looks like that. So the x and the y-axis, these are what we call asymptotes. That means the graph is getting closer and closer to the axis without actually ever touching it. Okay, and then the same thing in the fourth quadrant, that is an asymptote. This is what it looks like. This goes down. So it looks like that. And then this point here, let's say I was drawing the hyperbola xy is equal to minus 2. So I want this point here, which is the closest one to the origin over here. The coordinates here, this will be square root of 2. And this one on the x-axis, because it's negative square root of 2. And then I complete my rectangle. So this one is positive, so it's square
Miss, why is
root
it a
of 2.
square root of 2?
Because I want the product to be equal to negative 2.
Okay.
Yeah, so when I say square root of 2 times negative square root of 2, my answer will be equal to 2. Because any point I pick on the hyperbola, when I multiply its x and y coordinates, it must be equal to negative 2. And then this point over here, that is negative square root of 2. Okay, so I'm picking this point here, which is closest to the origin. This must be equal to this one over here. This is square root of 2. comma negative square root of 2. There's a question in the exercises, the last one, it asks you to prove what I'm saying now. We know that with the hyperbola, it says this, that the shortest distance of any point on the shortest distance from a hyperbola. To the origin is okay. So this is actually the formula for the shortest distance between the hyperbola and the origin. So k, here is your value. Like here we have xy is equal to minus 2. So this is my k, and then when I take the absolute value of minus 2, this is just equal to 2. So you can try this and find out why is it the case, and then if you cannot get it, then we'll go over it tomorrow. Okay, so that is the first hyperbola to draw, the rectangular parabola. So when you draw it, I also want to see it labeled like I've done here. X, y is equal to minus 2. It must be in the right quadrants depending on your value of k over there. I would like to see the rectangle drawn, and that's pretty much it. So with the hyperbola, it's very easy. It's either in the first and third quadrant or in the second and fourth quadrant. Okay, and then your rectangle with the correct coordinates given over there, and that's it. Then we have the central hyperbola. With the central hyperbola in standard form, it looks like this. We have x squared over a squared minus y squared over b squared. This is equal to 1. It is always equal to 1. Now, most of the time you will not be given an equation where it's equal to 1. It is up to you to rewrite it so that it is equal to 1. Now, what it looks like is this. So this is your hyperbola. This is what it looks like. The coordinates over here, this is a. This one here is minus a, and then you have b somewhere here, and you have minus b over there. So this also forms a rectangle. I hope you can see my rectangle. Okay, so you form a rectangle like that. Okay, then what you do is you connect the vertices of the rectangle like that. You see that one, use a different color. So you connect the vertices, that one and that one. You take a straight line that passes through the origin like that. And then this vertex with that one, you draw a straight line that passes through the origin. These are your asymptotes. Okay, so remember, asymptote is just a line that a curve gets closer and closer to, but it doesn't actually touch it. If we look at this one over here, you can see our line, it's getting closer. We draw it better. It's supposed to get closer and closer to the x-axis without actually touching it. You can see that's where it's going, but it never actually reaches it. Now here, your asymptotes were x and y. Now in this case, these lines in red, those are your asymptotes. So if draw it better, maybe it's best to even draw the asymptotes first. So you have your asymptotes like that, and your graph should look like it's getting closer to them without actually touching it. And then that's how you draw it. So those are the things that I would like to see, and then it must be labeled. x over x squared over a squared minus y squared over b squared. This is equal to 1. Now let's look at an example of how to draw this one. Let's say we have 3y squared plus 27. This is equal to 9x squared. So first thing, I must bring the x and the y to the same side, and it's x squared over a squared minus y squared. So when I rewrite this, I have 9x squared minus 3y squared plus, sorry, let me take it to the other side. This is equal to 27. All right, then what I have on the right hand side must always be equal to 1. So to make 27 equal to 1, I have to divide by 27. So I divide by 27, and what I do on one side, I must do on the other side. So here, when I rewrite this, this is x squared over, when I simplify this, I will have 3 minus y squared over, then when I simplify that, I will have 9, and this is equal to 1. So remember, very important, in standard form, this number here must be equal to 1. Then now I have to rewrite it in that form, a squared and b squared. So to do that, I will say this is x squared over the square root of 3 squared. The square root of 3 squared is just equal to 3. And then y squared over 3 squared, because 3 squared is equal to 9. So from here I can read directly what my a is. So I know that a is square root of 3 and b is just equal to 3. Then I draw my graph. So remember how we did it? It's over here. This is your a minus a, and then b goes on the y-axis. That's it. So draw my x and y-axis, then label them. So this must be labeled x and y. And then we said a is square root of 3, so I'll put square root of 3 there. And then I have minus square root of 3, and b is 3, so 3 will go somewhere there, 3, and then minus 3. Then we say this will form like a rectangle. Then I said I'm going to connect the vertices of the rectangle like that, passing through the origin. Use a ruler, then the other way as well, and then my hyperbola should pass through these points over there, and then these lines that I have drawn should be asymptotes. So let me start with this one. You can see it's getting closer and closer to the line without actually touching it. And the same thing in the bottom, getting closer and closer without touching it. And then the other side does the same thing, without touching, without touching. Then I must label. This is y. This is my hyperbola. What was the equation? Okay. So I have x squared over 3 plus minus y squared over 9. This is equal to 1. So this is me labeling my parabola, my hyperbola, like that. Okay, so it's very simple to draw. I didn't see a lot of questions in the exercises on the hyperbola, so I think this was the only one I could find. but you do it in pretty much the same way, and I think you'll agree that it is not very difficult to do. Do we have any questions? Or is it fine? Are you able to draw a line, a parabola, and a hyperbola, whether it is central or it is in rectangular form? I guess your silence means yes. If you have the book, let us just look at some of the equations over there. Okay, this is on page 104 in your book. It says you have to make sketches of the following. So if you have the book, I'd just like you to tell me, if you look at number 1, what shape or what is that? Is that a line, hyperbola, parabola? What is that? You can unmute your mics so you can tell me. I just want to make sure you guys understand. Anybody?
Exercise 9.5.
Yeah, 9.5, page 104. Question 1. What is that?
A line.
It is a straight line. Number 2.
A line, I think.
Okay, yes, it's also a line. Number 3. Where's the rest of the class? Are you guys still there?
Number 3 is also a line, ma'am.
Number 3 is also a line. Number 4.
Line. I'll say it's a line.
Is it a line?
I think so.
Yes, yes,
Yes.
Yes.
Yes,
Yes.
number 4 is a line. Number 5.
Parabola.
Number 5 is a
Parabola.
parabola. Number 6.
A parabola.
Yes. Oof, the rolling. Okay, number 7.
Number 7. Parabola, I think, as well.
Parabola. Yeah, number 7 is also a parabola. Number 8.
Parabola.
Number 8. Is that a parabola?
Yes.
Yes, number 8 is a parabola. Number 9. Number 9, we haven't
Hyperbola.
done that. No, it's not a hyperbola. The hyperbola,
it's
it
a
might
circle,
be a
ma'am.
difference. It is a circle, yes. So we'll do a circle and the ellipse tomorrow. But number 9 is a circle. Number 10.
It's a
Is
circle also.
Is it a
Circle as
circle?
well. Yes,
Yeah.
ma'am.
Okay.
Yeah. The circle. With the
Mm,
center, I think not at zero.
the center is, no, if the center is not at 0, it doesn't look like that. If the center
It
is
doesn't.
not at 0, you
Oh
have
yeah, yeah,
x
yeah. It's not.
minus h
Yeah.
and um,
Yeah, that's
and
number 13. The one that is
mm,
with the center not at
yeah,
zero.
number 13 is a circle where the center is not at 0.
Yeah. But
Oh,
this
at the
one is
origin,
just a
sorry.
circle. This
It's
one is
just a
just a
circle.
normal circle. Yeah.
Is it just a normal circle?
Yeah, it's just a normal. Yeah,
Hmm?
it's just a normal circle.
Okay, so we'll do the circle, the ellipse tomorrow. So you can look at the rest, number 11, 12, 13, all the way up until 20. Now 20 is an interesting one because here you see power 4, but you can actually make it one of the others. Now to do that, you'll have to change your x and y axis. Instead of plotting just the x axis, you can rewrite that as something else. So for the ones that we have done, go and practice the drawing the line, the hyperbola. I see number 14. That one is a hyperbola that you can sketch.
Yeah, yeah. This
Number
one is
17 as well. You can sketch that one. It's a hyperbola. and all the straight lines, you should be able to draw them. Okay, do you have anything else to add? Questions, comments?
Max, I want to take you back to the first hyperbola that you did.
Yes.
My sound was not well. I think I have a question somewhere there. You can
What
just
is
go back to
what is your question? The rectangular one, you mean?
the rectangular one.
This one. Is this the one you
Yeah,
mean?
that one.
Yeah.
Yeah. If you can just go back to the question where we started.
It's here. XY is equal to 2. And then I drew the sketch here. So this
So
is
that
just,
means now, yeah, I just want to ask on the number there. That means that now that two, the two that you have there is coordinate. Is how can I say? Is the coordinate?
no, it's the
How much?
product of the X and Y coordinates. So you see this
So
point
you,
here? Yeah.
yeah.
So this point here, the coordinates are square root of 2, square root of 2. Those are the coordinates. And when I
Okay.
multiply them, I get 2, like that. So I'm looking for points that when I multiply their coordinates, the answer is equal to 2. The shape they
Two.
form will be this hyperbola. Yeah. Mm-hmm.
Okay. Let me see.
Right.
So the square root of 2 is you just use it to. That's where I don't understand.
This square root of 2 is the shortest distance from,
From 0 to
yeah,
the coordinate.
and that point over there will have those coordinates. Any other point you pick, you will see that the distance is now longer. It's further away than square root of 2 and square root of 2 from there. So if you pick two numbers, you multiply them, and the answer is 2.
2.
The I don't want to say the shortest distance they can be away from the origin is if they are both square root, or if the coordinate is square root of 2 comma square root of 2. That's what I mean.
Okay.
Yeah.
Okay. No, and I get that. I just have to practice.
Okay.
Thank you, man.
Any All right. Anything else? Are we all fine? Okay. So
The
with
other
these ones, it's yeah.
the other things I think I've missed the class since last week. Where I don't understand, maybe I'll ask later.
Okay, but make sure you watch the videos as
Yeah,
well.
I want to go through. Yeah, I want to go through the video first.
Okay. All right.
Okay.
Okay,
Thank you,
so
man.
please try the questions that we have done, the line, the hyperbola and the parabola. Try and draw the sketches. Remember all those things that I want to see. I need to see the X and Y intercepts labeled. Your graph must be labeled with hyperbola, your turning point. It must be clearly shown this is the turning point. With the hyperbola, I need to see the rectangle in both cases. And with the central one, I must see those asymptotes, and your graph must look like it's getting closer to the asymptotes, but never actually touching it. Okay, so if there's nothing else, then I will see you guys tomorrow. Tomorrow our class is
Okay.
at,
7:30.
is it 7:30 tomorrow? No, 7:30 is Wednesday and
Which time?
Thursday.
Which time parable are we using? The old one or is
No,
the
we're
new one?
using the normal timetable. Tomorrow is Tuesday.
Tuesday. Yeah.
So
Okay.
Tuesday,
No
our
problem.
class is it 9:30 or 11:30? It's one of the two, either 9:30 or 11:30. Okay, so we'll just
11.
check it.
It's
11:30.
9:30, miss.
Okay, then I'll see you guys at 11:30. Okay, have a good day.